A common activity for AP chemistry is to be given a ion or a molecule and be asked to simply draw its structure. And the trick is to draw them because they don't really fit. When you actually try to draw a reasonable Lewis structure, you can't do it. So you go ahead and you expand your octet for these things. And let me show you a couple examples. Typically, you're given a list of about 8 different things you're supposed to do, but it could be that you might be able to just do this based on common sense. Let's deal with the silicon pentafluoride anion, SiF5-. They want us to draw a reasonable Lewis structure for it. First off, I wouldn't recommend just doing all dots because there's just dots everywhere. For the bonds, draw lines. You can always change them to dots later. Second off, is it not obvious that silicon's going to be in the center and fluorine's going to be like all around it? So do that. Draw your silicon, draw 5 fluorines around it. Fine. Now count up electrons that you've accounted for. Don't forget that negative charge. And anything that's extra, put on the central atom. Bada bing, that's what we're going to do. So listen to me as I do the math. Valence electrons, 4 for silicon, agreed, 7 for fluorine. 4 plus 35 is 39, plus the 1 extra makes 40. Now, I'm not even going to draw anything. I'm just going to imagine that for the silicon and the fluorine, once we get to sharing, they'll each have 8. So each fluorine will have its 8. 8 times 5 is 40. I don't think I'm going to need a negative charge, a lone pair at all. And here's what we got. SiF5-, and there it is. So in terms of electrons, and that's what we're counting up there, 8, 16, 24, 32, 40. Now, I'll be honest with you, I was about to make a mistake that maybe you could do too. You would then add maybe another 8 when you do silicon. You start showing silicon with its 8. But no, those are shared. You've already accounted for them, so you don't need to do that. So you've already got your 40 electrons, no need for a lone pair. Let's make it go away and let's try one more. There it is. Let's randomly pick SF4, because maybe that one will need some lone pairs. Okay, here's my analysis. I'm going to draw sulfur with 4 fluorines around it. I'm going to say that sulfur has 6 valence electrons, and each of the fluorine has 7. So 7 times 4 is 28, plus the 6 is 34. And when I draw those 4 things around it, it'll be 8, 16, 24, 32. I need 2 more electrons. I'm going to stick them on sulfur. What do you want to bet sulfur in SF4 has a lone pair on it? SF4, and there it is there. That's how you do it. Now I'm going to show you these listed rules, but I'm probably going to recommend that you don't do it. If you say, I have no idea what you're doing, you can rely on these lists, but you may find that after doing it a few times, you don't need it. I'll go ahead and read through it. Number 1, count the number of available valence electrons using the group number on the periodic table. This is 4 plus your 7 times 5 plus your negative. Draw the skeleton. And use any honk rules or any common sense that you can. In almost all cases, it's one thing followed by a bunch of things. There's no exceptions here. So just put your loner in the center. Place 2 electrons in between each pair of atoms. Why do they say it that way? Why not just say bond them? So bond them together with your lines. If they ask for a pure Lewis structure, electron dot structure, replace your lines with 2 dots. Fill in the octets for atoms for the P block. I think that means add lone pairs. And you know that the F fluorine, for example, has 3 lone pairs of electrons. They're all halogens here, so it's always 3 lone pairs. If you use more than available, make multiple bonds. That's interesting. So that could actually play a role. If you had too many, I don't see a single one here where we had to make multiple bonds. But if you already are in the extra realm, turn into a double bond somewhere. I mean, it's symmetrical, so it probably doesn't matter where. And that should account for having too many electrons. And if you have any extras, put them on lone pairs on the central atom. So this is expanded octets.